Okay, so everyone has green on the left, notes on the right. All right, so today we were talking about it earlier. We had we started at least this chapter itself, right? We started with one-step equations, two-step equations. We sprinkled in a little bit of extra stuff like rational coefficients and problems with distributed property. But then we turned around and we went into inequalities, right? Well, today we've been talking about one-step inequalities. Today we're kind of taking like 2 or 3 different little lessons that we had before, and we're wrapping them all up in one lesson, and we're just doing two-step inequalities. All right. So here is our one word today, and that is exactly what the name of our lesson is: two-step inequality. Everyone.
Two-step inequality.
So this is an inequality that contains two operations. An inequality that contains two operations. So this is what it will look like. 2x plus 2 is less than 8. By the way, don't get that confused with our POD, right? It looks very similar, but it's not giving us, it's not defining the variable. We have to find out what the variable is, like everything else we've been doing. So it looks just like a two-step equation, except it has an inequality sign. All right, so here's what I'd like you guys to do. Go ahead and that's it for vocab. So go ahead and grab. Actually, we're going to start with our book page. So go ahead and go to page 516. All right, eyes up here when you're ready. Problem number 3. All right, one person's ready to go. 2, 3, 4, 5, 6, 7, 8, 9, 10. Thank you, guys. All right, so problem number 3 on 516. Let's go ahead and close read it. All right, it says financial literacy. A rental car company charges $45.
Plus
20 cents per mile to rent a car. Mr. Lawrence does not want to spend
more
than $100 for his rental car. Write and solve an
inequality
to find out how many
miles
he can drive and not spend more than $100. Interpret the
solution.
All right, so here's what we have. All right, so I'm not going to go into great detail about this first step. We're just going to call it step 1. And step 1 is let's go ahead and build a bar diagram. We've been doing this long enough to know how to kind of set it up. So bar diagram, right, just to sort our thoughts out. A little graphic organizer. So we have on the top, I need to put the total amount that what basically this character, Mr. Lawrence, is comparing everything to. So on the top, it is going to be, it says he does not want to spend more than $100. That's his limit, and that's kind of his total limit, right? We're going to put $100 up top. Okay, now on the bottom right is actually how much he's truly going to spend. This is where our expression comes from. So on the bottom it says the rental car company charges $45 plus. Well, before I even read any further, I'm already thinking the $45 is just that one-time fee we've talked about. So that amount, let's say it's $45. Before he even pulls the car off the lot, it's a $45 flat fee, one-time fee, okay, that he has to pay. Now comes the next part, right? Plus 20 cents per mile to rent a car, okay? So if he goes 1 mile, right? That's how much it would be. But we know he's going more than 1 mile, right? He's not renting a car to just go 1 mile. All right, so 20 cents for the second mile, 20 cents for the third mile. And again, like we've talked about many times, this is, of course, going to be repeating. And we just don't know how many of those there are. Okay? Now, if I reread the question part or the task part of this, it says, write and solve an inequality to find out how many miles he can drive. Of course, is 20 cents per mile. How many miles he can drive is, of course, going to be our variable, because that's what it's asking for. So, here's what I'm going to do. I'm going to start by, we have our bar diagram, so step 2, I'm going to go ahead and use it to write our inequality. All right, so I have my $45 he has to pay. It actually says right in that problem, right? Plus 20 cents per mile. It's repeating, right? So remember, if it was 2 miles, it'd be 20 cents times 2. If it was 5 miles, 20 cents times 5. 10 miles, 20 cents times 10. So it's 20 cents times however many miles that he drives. Well, remember we said that's our variable. And you can put M for miles if you want, okay? Or just put the basic X for right now. So we have $45 plus the 20 cents times the mileage. And remember, it's being compared to the $100. Now, I'm going to go ahead and I'm going to put step star here because like we've talked about before, finding out what the inequality, if it was an equation, we just put an equal sign and move on, right? But the inequality could be challenging for some of us. So our little step star, our reminder part is that we need to slow down at this point and put the correct inequality there. All right? So you're going to hear me say every single time, you're going to hear me go through these questions to myself. Okay? Remember, first of all, this is how much he's going to actually spend. This is what we're comparing it to. So, the $100. So, according to the story, how much he spends, I always start with this question. How much he spends, can it be equal to $100? And it'd be okay. He has $100 in his pocket. How much he spends, can it equal to $100?
Yes.
Yes. So I put, we know it's going to be an inequality right now, so I'm going to put just the half equal sign. So that is part of our inequality sign. Now I go and I try out the other two. Meaning, can this be less than that? Can this be more than that, right? So let's ask, can he spend more than $100 and be okay? No. Can he spend less than $100 and be okay? Yes. So I put that less than sign. And that's how we come up with the correct sign. Ask yourself those 3 questions. Is it okay if this is going to be equal to that? Of course, the whole point is you've got to know what each parts of these, and this total right here is always what it's going to be compared to. The expression is, of course, whatever you're trying to find out. In this case, how much he's going to spend. Okay? Depending on his mileage. All right, so, ta-da! There's our inequality. All right, that's our inequality. So now, after you write that down, I'm going to rewrite this inequality down. So after we write that down, I'm going to go ahead and we'll do step 3, and that is we're going to solve this 2-step inequality. So here we go. It's just like a 2-step equation. We go ahead, remember, box in our what we call our variable term, which is the variable with the coefficient in front of it, okay, or if it's being divided by a number. And we do additive inverse. Remember, it's addition of 45. So what I'm going to do is I'm basically subtracting that 45 flat fee. Whatever we do to one side, we do to the other. So those cancel. We end up with 20 cents times x is less than or equal to. And by the way, I don't have to flip the sign because all I did was subtract, right? And it only works with multiplication and division. So we have 100 minus 50 is 50. 100 minus 45 gives me an extra $5, so it'd be 55. Of course, now it's just a 1-step inequality. I box in just our variable. It's on that left side, so we stick to that left side. It's being multiplied with 20 cents, so we divide by 20 cents. Bless you. Whatever we do to one side, we do to the other. So these cancel. I have x. I take a look. I do not flip my sign. I keep it the same because this is a positive 20 cents. So I just bring my inequality down. And now, calculator time on this one. 55 divided by 0.20, 20 hundredths, equals 275. And there is our solution. All right. last but not least, step 4. Remember, we have that last part, interpretation. We just got done talking about this a bit ago. Remember, with an interpretation, I'm going to put this right here. As a little reminder in our notes, I'll put 1, 2, 3 as a reminder that I need to write down what the meaning of this is, what the meaning of that is, and what the meaning of that is. If I go one step at a time, take my time, I should be able to get at least an okay interpretation. All right? So here we go. My x. Let me reread again. What is x? Well, the x, remember, is always what it's asking us to find. And it says how many, I'm reading the wrong one. Write and solve an inequality to find out how many miles he can drive. That's what x is. The amount of miles that, what's the guy's name? Mr. Lawrence. The amount of miles Mr. Lawrence can drive. I'm going to start with that. So the amount of miles that Mr. Lawrence can drive. That's just my start, right? And now the inequality sign. So that's part 2, right? This is a less than or equal to. Now again, if you want to make a better interpretation, use your notes. Use some of the wordings that we have in our notes. But in this case, you can always use the name of this. So is less than or equal to. And I'm going to write that. Is less than or equal to. And I'm going to pause for a second. And then we're going to write 275. But I need to know what kind of units. So if I actually, you can almost reread this and it will tell you the amount of miles that Mr. Lawrence can drive. There you go. It's miles. The amount of miles that Mr. Lawrence can drive is less than or equal to 275 miles. Get your units on there. And we are done. And that is an interpretation. Okay. Now, remember I was saying that our lesson, if you understood today's lesson, you would have a very good chance at doing well on next week's test. Okay? That's because, guys, this is just like a two-step equation, right? It is, you're dealing with an inequality, you're dealing with an interpretation, you're dealing with a lot of different things. The next problem we'll actually do some graphing, which, we'll review that really quickly, but it's kind of the same stuff. I mean, if you can handle this problem, you have a good chance of doing really well on next week's test. Okay, so before I let you guys try it, time for questions. Any questions? Okay. All right, here we go. Flip over to your homework on page 519. Try out problem 22. I know it's kind of a lengthy problem, right? You have 3 different answers to it. So on 519, problem 22, I'll check in with you in 2 minutes. Go. Okay, checking in. How many of you need more time? Okay. Those of you that got that done, you can actually, I believe, work on a majority of your book page there. Little reminder, tonight's the last night to get your log signed, so make sure you don't forget. All right, checking in with you guys. How many of you still need more time? All right, give you about another 30 seconds and check in one more time. All right. Anyone need more time? Okay. All right. So I'm going to give you guys 1 minute to share, and the reason is because, and what I would do is I'd start with your solution. All right, because if your solution's off, then definitely take a look at how you compare your inequalities up here. Okay. If your solution's right, however, then after you get done with that, then talk about your interpretation. And they can be different, but have the same meaning. But make sure they have the same meaning. Okay. So 1 minute. Go ahead and turn to your partner and share. Go. All right, here we go. Let's take a look at problem 22. First off, I want to look for an inequality that you guys may have, an inequality. All right, so let's check this out. Sheet 3. Just the inequality, not the solution. So the whole sentence, inequality sentence. How did you solve it if you didn't write one of those? If you solved it, you probably have it on there somewhere. Like that? Okay. Agree, disagree. What do you guys think? Okay. All right. A few agreements there. Okay. Anyone have another? Anyone want to volunteer which inequality they had? Okay. All right. Let's check this out. I take a look at number 22. Right. It says, Katie's starting a babysitting business. She spent $26 to make signs to advertise. She charges an initial fee of $5 and then $3 for each hour of service. Write and solve an inequality to find out the number of hours she will have to babysit to make a profit. Interpret this solution. Now, it's been a while since we've talked about profit. Okay, and to be able to solve this, you have to know what profit is, right? So let's say we're doing a fundraiser for band, choir, sports, whatever. We're doing a fundraiser and they're selling candy, right? If the box of candy, I had to buy that box of candy from the manufacturer for $25 and I turned around and sold it to someone for $27, what was the amount of profit I made? $2, right? It's basically the profit is the amount of extra money you make, right? Because the $25 has to go back to the business. So basically, we have to, and it sounds like you guys have a pretty good idea what profit is, okay? So if I take a look here, if I draw a bar diagram, right, I'm looking, remember that the total that she spent, okay, that's what we're comparing it to, is the total amount that she spent to make those signs was $26. Now, of course, we will, of course, want to know, right, profit, she needs to make more than that. But how is she going to make more? Well, it says she charges an initial fee of $5. An initial fee, it's not for every single sign or whatever else. It's just $5 flat fee. Okay, that's very much like the $45 flat fee for the renting the car up here. That's kind of what that is. Okay, then it turns around. It says she's going to charge $3 for each hour. So here's the first hour, $3. Here's the next hour, $3. Here's the next hour, $3. Of course, the question is how many hours does she have to work? We don't know. That's actually going to be our variable as well, the amount of hours. So to write this, it's our flat fee plus our $3 an hour times however many hours she has to work. We don't know. We can write H for hours, X for hours, it doesn't matter. This is being compared to 26. Now remember what we talked about earlier. This is the total. This is what it's being compared to, but this is what we're really looking at. So is it okay if the amount of money she makes is, remember we're talking about profit, is it okay if she makes equal to $26? No, there's no profit if she makes, that was a horrible business that she went into if she made exactly equal what she already spent, okay? Is it okay if she makes less than what she's already spent? No. Is it okay if she is greater than what she already spent? Yes, that's what we want. All right. All right, nicely done. Okay. So there's your inequality. Now at this point, it's like a two-step equation. I box in our variable term. 5 is positive, so I'm going to subtract 5 from both sides. We get the positive 3x. And I'm only subtracting here, so the sign stays the same. 26 minus 5 is 21. Now, box in our variable here. It's being multiplied with 3, so we divide by 3 here and here. That cancels. We have x. We divided, yes, but it's still a positive number, not by a negative. So the sign, again, remains the same. 21 divided by 3 is 7. And there's our solution. So our inequality sentence up here, our solution there. Now comes the interpretation. So remember, I put 1, 2, 3 here because we're going to find out what x is, what that sign is, and what 7 is. So X, remember, reread the question if you need to. It says, find the number of hours she will have to babysit. There it is. So her name was Katie. So Katie will have to babysit. That's a greater than sign, so that's the second one. So greater than. And then, of course, 7. And that last part, 7 what? She'll have to babysit greater than 7 hours. Put our units on there. So you're absolutely right. Remember I said, if you do it my way, that simple way, it will make sense. It will have the same meaning. It's not the best sentence that you're going to get in the world, right? Because realistically, you should say, you know, Katie will have to babysit more than 7 hours to be able to make a profit, right? So that would be the best sentence, but that is still okay. All right? That's adequate, average. All right? So, inequality, solution, all right, interpretation. Any questions on that? All right, really quickly, we are not going to do this whole thing, but I do want to get you started on problem 24. So we're going to do part of 24. You'll have to finish it off for homework. But let's take a look at problem 24 really quickly. Another word problem. I'm going to help you write the inequality. The solution and the interpretation you'll have to write on your own, but I'm going to help you write the inequality. So here we go. Let's close read this. Elijah and his sister went to the movies. They had $34 and spent $9.50 per ticket. Elijah and his sister bought the same snacks. Write and solve in for the amount that each spent on snacks. Interpret the solution. Okay. Now here's the reason why I want to do this with you, because it's kind of like the one we did on Most Missed a bit ago. It has a little twist to it. It's not kind of your basic one like this. It has a little twist. So you have to do a little extra thinking. All right. A little inferencing a little bit while we're writing this. So I'm going to go ahead. Steps are still the same, guys, so I'm not going to write the steps. I just want to do this with you. So we have our pencils warmed up, so let's get going. So I have my bar diagram. I'm going to go ahead, and on the top, I'm going to write the top. Well, first of all, right, you're talking about them going to the movie, spending some money, but the problem is they have $34. That's their limit, basically. So $34 is the total. So 34 is what goes on top. Now, like I said, there's a couple little twists here. Okay, first of all, it says they spent $9.50 per ticket. All right? So as soon as we see the per, many of us think, there you go, there's the variable, we're going to multiply by X, and actually no. Because look, here's $9.50 to get in for Elijah. Here's $9.50 to get in for his sister. And that's it. That's basically like having 2 flat fees, and that's it. Boom, boom. Right? It's not like we need to find out how many friends. It's a bunch of friends getting in. It's $9.50. Okay? Then we turn around, and it says they bought the same snacks. All right? So we have 2 different snacks that they bought. Awesome, thank you. Okay, so they bought the same amount of snacks. This is a little different because here's what we have. Elijah's snacks, how much are they? We don't know. We're going to use S for Elijah's snacks. Or X, it doesn't matter if you use X. Here's his sister's snacks. S. There's no repetitiveness. The variable is the amount of money that we don't know. And if you reread, right, it says, write and solve an inequality to find the amount that each person spent on snacks. That's the S. So now when we write our expression or our inequality here, we have basically $9.50 plus $9.50 plus S is being compared to $34. Now here we go. We write our inequality. How much they spend, can it be equal to $34 and they'd be okay? Yeah. They can spend $34 exactly and it'd be all right. Can they spend more than $34? Nope. Can they spend less than? Yeah. So this looks a little weird, right? Well, guess what? It's been a little while since last chapter, but we're going to combine like terms. So, ladies and gentlemen, there's our number, 950 plus 950. Yeah, it's 19, right? 9 plus 9 is 18, but you have 2 extra 50 cents, which is $1, $19. Plus, and then look at this. S plus S, or 1S plus 1S is what? 2S is less than or equal to $34. Okay, so like I said, it's a little different than the other ones we've been doing, so I wanted to make sure I kind of introduce that to you guys. And then don't forget, you'll still have to get this right. You'll have to solve for the solution and get the interpretation, but I wanted to get that with you. Okay, any questions about that part? Okay, I want to do one more type of problem with you guys, all right, and it is off of our worksheet. So go ahead and grab your worksheet. Get your name and period up at the top. All right, this worksheet I like, but there's parts of it I don't like. So let me show you. First of all, if you take a look at row 1. There's only one number. So when we correct this tomorrow, okay, this is problem 1A. We'll call this 1B, 1C, 1D. 2A, B, C, D. Okay, like that. 3A. But then take a look at the bottom. They actually give each of them separate numbers. Okay. When we correct this, by the way, each of them are going to be a different problem. Okay. So what I want to do with you is what we will consider 2B, which is row 2, the second one over. We'll call that 2B. Okay. Okay, so you're going to see we've already solved the problem like this. Like I said, the main part of this, doing the worksheet, is just a little review on graphing, which you guys should be okay with, but I wanted to do one with you. So here we go. Step 1 with a 2-step inequality is box in our variable term, 5/10 times x. Okay. Of course, step 2, that tells us which side of the inequality to go to. So step 2 is go to that side. It's a positive 6.25, so we're going to do additive inverse. I'm going to subtract 6.25. Okay. Step 3, whatever we do to one side, we do to the other. So I subtract 6.25 here. So I go ahead and do step 4, which is, let's simplify this part. So we have, because these cancel, so we end up with 5/10 times x, 0.5x. We do not flip the sign, right, because we're only subtracting. And then 8 minus 6 is 2, decimal point comes down. 7 minus 2 is 5, 5 minus 5 is 0. And now comes step 5, and here's what we'll do. We'll keep this easy. We'll just say repeat, all right, and this is a one-step equation, okay, or inequality in this case. We're going to go ahead, box in our variable only. We go ahead, it's multiplied by 5/10, so I'm going to divide by 5/10. Whatever I do to one side, we do to the other. So we end up with x, and I take a look, right? No negative still, so I just bring down my sign, and this is the part that I'm going to use, punch my calculator. 2.50 divided by 5/10, and I get 5. So our solution is x is greater than 5. Okay, that's our solution. And then we'll just call this step 6, and that is just, we're going to graph the solution, guys. So here we go. Find your 5. Well, take a look. They didn't number the number line. So listen, I'm just going to have you do the basics. Just kind of choose a middle line here. Put what the variable is being compared to, which in this case is 5. So I'll put a 5 down there. Remember, if there's an equal sign, you put a dot. If it's just an alligator mouth, you put a circle. So just an alligator mouth, I'm just putting a circle there. And last but not least, we're graphing the x, and I know that x is larger because alligator mouth is eating it. So I need to point my arrow to the larger numbers, which is to the right. And there's our graph. All right. Questions on that type of problem? As you can see, right, some of these problems here I probably didn't even have to teach you. I bet many of you guys would have already known, right? It's because it's like a two-step equation. You solve that, you graph the solution the same way, so it's very similar. Chris?
The first thing was I was saying where you can have a show work there.
Yes, thank you for asking that. Yeah, you guys will need to show your work on all of these. Okay. You're gonna have time to work on it in class today, so yeah. Any other questions, guys?
So we don't have to put numbers on each of the lines?
Nah, you don't have to put numbers on the number lines. If you want, you can. Okay. If you put numbers on the number line though and you number the number lines wrong, I'm gonna have them marked wrong. So I actually like you putting numbers on the number line. You don't have to, but if you do, please be very careful. Okay? Especially when you get to the negative side. A lot of people forget how to number a negative side of a number line. So make sure you're careful with that. Other questions?
We have to show work on every single one of this one correctly.
Okay, guys, let's answer. We have to show work on every single one?
Yes.
Okay. Any other questions? All right. Here's the one I want you guys to try. Problem number 5. Problem number 5. Try that out. All right. It's kind of a long problem, so I'll check in with you in about 1 minute. Okay, go. Okay, anyone still working on that? All right, I'll check in with you guys about 15 more seconds, or I'll give you about 15 more seconds. If you've already finished that, like I said, I mean, those are the only type of problems, so you can get going on your homework until we share with our neighbor. Okay, so 30 seconds. Make sure, guys, when you share your solution and also share your graph. All right, share both. 30 seconds. Go. All right, here we go. First, let me go ahead, see what solutions are out there. Which ones? Here we are, seat number 28. X is less than 3? 5? All right. Agree, disagree. X is less than 5. Okay. All right. Any other solutions out there? X is greater than negative 2. Agree, disagree with that one? Okay. All right. Any others?
X is greater than 15.
Agree, disagree with that one? Okay. A lot of different solutions out there. Others? X is greater than positive 2?
Yeah.
Agree, disagree with that one? All right. Chris, what do you think? X is less than what? Negative 0.4? So negative 1 and 4/10, like that? Agree, disagree? Any others?
Yes. Finally.
X is less than negative 2. Agree, disagree with that?
I disagree.
Okay. All right, so that's the most popular. Not that everyone agrees, but it's the most popular. So, all right, well, I love it, right? Because I'm sitting there calling on people, and everyone thinks they got the right. Oh, let me share, and then everyone, what? No one's agreeing. All right, here we go. Let's try it out. Let's see which one of you guys. All right, here we go. Negative 5x minus 1 and 5/10 is greater than 8 and 5/10. So we go through our steps, exactly the same steps. I box in our negative 5x. Okay, I add 1 and 5/10 here, as well as here. Now, one of the things I can think of that previous students have messed up on this is when they add, they don't line up the decimals. So I don't know if anyone did that incorrectly, but let's check this out. So we have negative 5x. Okay, I'm only adding, so it's still greater than. And this, 5 plus 5 is 0 because it's 10, right? 5 plus 5 is 10, carry the 1. 8, 9, 10. Decimal point comes straight down. So we have negative 5x is greater than 10. Then we box in our variable. And we, of course, that's multiplied with negative 5, so we divide by negative 5. Okay. Some of us see the negative 5, and you guys, our inverse, our first thing is oh, I add 5 again. No. That's a coefficient. Remember, coefficients are multiplication. So you've got to remember that. Because when I did whiteboards with my groups yesterday, I saw a lot of that. Okay, be very careful with that. Because if you're still struggling with that, that's something you've got to clear up very soon. Make sure you ask yourself, is that a coefficient? If it is, that means those two are multiplied together. They're not added or subtracted together. Okay? So I go ahead, whatever I do to one side, I do to the other. Those cancel. I end up with x 10 divided by a negative on both sides of the inequality, and it is division. I flip my sign. So it becomes from greater than to less than. And 10 divided by 5 is 2, of course. However, positive divided by a negative is a negative. Okay. So I go ahead, negative 2, I'll put down here when I graph it. There is no equal sign, so I put a circle. And the x is smaller because alligator mouth is not eating it, so I go ahead and point an arrow to the smaller numbers. And there's our graph. All right. Questions? So the most popular one, of course, was the correct answer. But I can see, because of simple little mistakes, how a lot of those could have been the answers. So, and I'm sure, if you don't know what you did wrong, then make sure you let me know. I'll help you out. Questions?
So for the graph, for the number, you just put it right in the middle of the
Yeah, just put it in the middle. Yep. Middle's fine. If you want to put 0 in the middle and number it that way, I'm okay with that. I'm not too picky as long as you go to that correct number and you graph it the right way. Okay? Any other questions, guys? All right. Two-step inequalities.